Okay, so welcome to the first lecture of power electronics. Before I start the lecture, I want to show some tentative logistic about the lecture, about the whole course. So there are going to be lecture roughly 15 or 16 hours, and then tutorials around 9 hours, and practical activity around 12 hours. So I don't need to go too detail into here. So the first lecture is Introduction to Power Electronics. I guess it's better to make a full screen here. But if I put them full screen here like this, oh, how can I have, yep. Okay. So I will introduce a little bit history, not a little bit, but a little bit long history. Actually, electricity was discovered in 1759 by Benjamin Franklin. But electricity became useful when after the invention of induction motor by Nikola Tesla. At that time, Industrial Revolution 2.0 exploded because manufacturer can mass produce products. Okay? But a little bit back, before the invention of induction motor, actually, the electricity at the time, there were two types of electricity. People try to decide whether they choose DC or AC to power the grid. So at that time, Thomas Edison was very famous. He invented the light bulb, and he also proposed DC current to power the grid. Okay. But then Nikola Tesla introduced AC current, alternating current. There was a rumor that there was conflicts between the two ideas. But then, after the invention of induction motor, which use AC current, then AC voltage source became the one that powered the grid for city, okay, and for manufacturing. So what do we need power electronics for? Well, so you already see that we have the power from the grid as AC, okay, alternative current, okay, from power plant transmission until to the residence. Then you got the AC power source from the socket, right? And but most of appliances, not all of them, but most of them use DC. Okay, DC current. For example, so I will just pick up the one that is very surely that it use DC, because this is a vacuum. It's a cleaner robot, so it has battery. So battery is DC, type of DC source. It need to charge. So in order to charge to the robot, you have AC power source there. You need to charge the battery, which is DC. So what do you need? You need a converter from AC to DC. See? And for the laptop also, it has battery, and everything inside here use DC. But you have power source as AC. So you need the adapter. Sometimes you call it adapter, sometimes you call it charger, because it can also charge battery. You call it adapter because You use power source 100 volts, or you use AC power source 220 volts, it still can work. So it kind of adapter. So among these appliances, perhaps most of them use DC, and some of them still use AC. So, but I don't look into detail of those appliances. So, what is the device that is used to convert from AC power source to DC? So it's called rectifier. Okay? Yes, some of you mentioned rectifier as a device to convert. I mean device of power electronics. And you can also see application of power electronics in power generator from wind turbine. So you know that the grid has to be AC, right? AC. And here around here is medium voltage. After this one is high voltage. Okay. So this is medium. This is high. After this transformer, this is medium, like that. This is also lower medium, and this one is low voltage. Well, for the power plant, you can see from power plant is medium voltage. I would say, medium voltage. And this one also a type of part of power plant from wind turbine, from a set of wind turbine. And so in here there are many power electronics components which function different way. Okay, so the generator actually generates AC power, but because due to the variation of wind intensity, wind velocity, sometimes it's been too fast, sometimes very slow. So the voltage, AC voltage generated here cannot be the same as one on the grid, right? So you need certain power electronic to convert in many ways. Actually, first convert to DC, and then in an inverter convert DC to AC that has the same frequency as the grid. So you can see here several power electronics device inside. Okay? And so you hear the term inverter that convert from DC to AC, and you need the frequency of the output from inverter the same as that of the grid. So it needs kind of control. If not, without control, maybe you get a random frequency which does not match the frequency of the grid. And here, maybe you have heard of modern refrigerator that use technology inverter, right? People say, oh, this refrigerator has inverter and it saves energy compared to the conventional one. So what is inverter then? So for the refrigerator, when you operate it, when you open it, so much heat is exposed into the food inside, the voltage increase. At that time, the refrigerator, the whole set of the refrigerator has to work hard, right, in order to lower the temperature. So inverter, in some sense, it can produce more power when the inside of refrigerator is needed. Okay, but you need to lower temperature quickly. So inverter, in some sense, it can provide much power wide range of power from low power to high power. For the conventional refrigerator, it does not have such property. Conventional is just switch on and switch off. If you need to cool down, switch on. Then if it's cool enough, switch off. Okay. Let me explain a little bit more more technical term for inverter. Actually, the motor is AC, a kind of AC motor. So AC motor, when you want it to work hard, you need to spin fast. Okay. If you want it to work not so hard, it spins slower. So inverter is a kind of electronic device that can generate AC power, AC voltage that change frequency to change the speed of the motor, the change frequency and also the amplitude of voltage. Okay, so actually this kind of technology just came out not too long ago. And for power on solar power off grid, you can see here you can have solar power and then you have a battery backup. You have and you want to use the power in residential home. So all appliances inside the house use AC power, right? Yeah, your rice cooker, you bring the plug and you plug it into socket. That's AC. But solar power generates DC. So what you do? If you want backup by battery, you need a charge controller that can charge your battery when you have excessive energy. But then you want to use with your appliance, okay? So you need a DC to AC converter, or it's called inverter. Okay? So from DC to AC, the component is called, device is called inverter. So what is power electronics in engineering term? So actually it's combination of the study on power transmission or conversion, and you need electronics in order to do the conversion, and also you need control. Why control? Because you need a particular output. Certain output has to be at this level of voltage, has to be at this level of frequency, for example. So you need control. Is there any question up to this point? Yeah, feel free to interrupt me anytime if you want to ask for more explanation. Yes, so here a little bit about history on the power electronic itself before I introduce history about electricity. Right? Actually, the first power electronic device, so-called mercury arc rectifier, invented in 1900. The next one, metal tank rectifier. You see the term rectifier all the time. See? Grid control vacuum tube rectifier. So what is rectifiers for? It's convert from AC to DC. There's many device power based on DC voltage, and you have power from the grid is AC. And then the first semi-control rectifier, this one, or so-called thyristor. It was invented by a lab in 1956, and so it's kind of the first kind of transistor. And again, transistor is electronic switch. Okay. And then the second electronic revolution started in 1958, and the first commercial grade thyristor produced by General Electric became available. And at that time, the era of power electronics rolled out. And then after that, lots of power semiconductor device and power conversion technique have been introduced, like rectifier, inverter, DC converter, and many things more. Actually, just want to draw more your attention about transistor. So after the invention of transistor, actually, it led to the Industrial Revolution 3.0, because transistor not only used for power electronics but also for logical gate, and logical gate used for computer. For the microprocessor, microcontroller, and so on. So, for example, inside Intel CPU, there are millions to billions of transistors. Just do the logic operation for calculation, okay, for arithmetic calculation and memory access, memory storage, and so on. So, Industrial Revolution 3.0 actually is due because of automation. So automation, machinery, robotics, and you see that this kind of robot is are driven by AC or DC motor, and these motors need driver, and inside the driver you need power electronics. So you can see that the Industrial Revolution came from invention of transistor is so enormous. Okay, power electronics, digital, and also analog, like op amp, but I don't mention it here. And application. So power electronics have many applications in commercial application, domestic appliances, industrial equipment, aerospace, telecommunication, transportation, vehicles, so on. And yeah, you can see the detail here. I mean, the name of device or equipment in here. I don't read it. You can read it later by yourself. So yeah, aerospace, telecommunication, transportation, you can see all here. Yeah, so that's all for the introduction. Do you have any question? No question? So you can take a break about 5 minutes.
The inverters, refrigerators, and another one is converter.
Conventional.
Maybe explain again.
Oh. Right. Okay, for the conventional Conventional refrigerator, actually, refrigerator is a kind of cooling system that it has a compressor to pump the refrigerant inside. Okay. So yeah, I don't explain detail about cooling system here, but just to give the idea. So it need to pump liquid inside in order to make the cool part cooler. Okay. Yeah, there are two parts. This one is cooling part, and this one is heating part actually. So I'm not expert in the cooling system, so maybe sometime I coin the terms not so correct. Actually, it has like a condenser, name of evaporator or something like that. Well, for the conventional, yeah, because this pump is driven by a motor, okay, driven by a motor. So the motor, okay, has electrical switch here. So when it need to cool down, it's just turn on and the motor run at full power. Okay, and when temperature reaches the set point, it just switch off, just on and off.
So how about the current used with AC or DC?
AC. Yeah, this one is AC. So okay. So actually, in order to avoid frequent switching on off to frequent, so there's like a threshold that just let it run even though the set point already reached, but let it run a little bit longer. And when it fall down to lower than the set point, but just let it stop a little bit longer. So it's not very efficient in some sense. But for the inverter so here you have inverter that can control the speed and the power of this motor, the inverter. It means if the temperature close to set point, it spins just a little, just cool it down a little, not too much. Okay, so there is no excessive cooling and not too low. I mean, too low not too low temperature. Yeah, actually inside the inverter itself, it has from EAC and then to DC, and from DC to AC again. So why? Because this AC this AC is from the grid. It has this one has fixed frequency. Okay, fixed frequency. But this one, you change the frequency depends on the speed you want to control the motor. Sometimes it can be frequency is very fast. Sometimes it can be very slow. Something like that. That is the usefulness of inverter. I think I would say this is inside inverter. Okay.
Sure. So in this case, you want to control that. Kind of in the software, you can use DND, right? You need that to turn up or turn down the temperature.
So okay, there are two levels of control. One is on the inverter side, okay, and the one is on the cooling room. So your question is about the cooling room, because the cooling room you need to use a temperature sensor in order to do the feedback to the motor to control the motor. Okay. So the set point is sent to microcontroller for controlling the motor. But yeah, the motor means including the driver. So inverter is a kind of driver. Okay. So there must be interpretation that if the temperature is at this level, then inverter interpreted what frequency or voltage level should be output to the motor, something like that. Yeah, you mentioned like PID. PIDs can be one of the controller. Any more question? Yeah, if no.